Hi everyone, I welcome you all to AJ Padasala. In this video, we are going to solve the intext questions number 2 that are given in page number 6. Now, let's read the question first. Write a balanced equation for the following chemical reactions. Hydrogen plus chloride gives hydrogen chloride. Barium chloride plus aluminium sulfate gives barium sulfate plus aluminium chloride. Sodium plus water gives sodium hydroxide plus hydrogen. Here they had given three different chemical reactions in the form of statement. So first we have to convert the given statement into its respective symbols and then we should try to balance it. So before we start to answer the given questions, now let's learn what is law of conservation of mass. This law states that mass can neither be created nor be destroyed in a chemical reaction. It means that how much mass of elements that we are taking in the reactant side must be equal to the mass of the elements that are present in the product side after a chemical reaction. So, before we try to balance the given chemical equation, first we should know what is law of conservation of mass. By keeping this in our brain, we should try to solve that is balance the given chemical reaction. The first question is hydrogen plus chloride gives hydrogen chloride. Here they had given the chemical reactions in the form of statement. So first what we have to do is, first we have to convert the statement into its element form, into its symbol. We know that hydrogen we have to write as H and chloride we have to write as Cl2 and hydrogen chloride we have to write as HCl. Okay. Now here we have written the symbol as H2 plus Cl2 which gives 2HCl. So we have converted the statement into its symbol. Now what we have to do is we have to check whether the chemical equation that we have written is balanced or not. For that we have to make a tabular column like this. Then in the first column we have to write as element and in the second column we have to write as number of atoms in reactant side that are present in the left hand side, and the third column we have to write as number of atoms in the product side that is RHS, and we have to list out the symbols elements. So for hydrogen it is H, so we have written hydrogen H, and for chlorine we have to write Cl, that is Cl. Now we have to see how many elements, how many atoms are there in the reactant side. First let's start with hydrogen. So here in reactant side we have 2 atoms of hydrogen. So here we have written 2. And how many atoms are present in, how many atoms of chlorine are present in reactant? That is 2. So we have written 2. Now we have to come to the left or right hand side, that is product side. In product side also we have 2 atoms of hydrogen and 2 atoms of chlorine. Now we have to compare these two. Okay, compare these two. Now both are balanced. So the number of atoms present in the reactant side is equal to number of atoms that are present in the product side. So both are equal. So this satisfies the law of conservation of mass. So now the equation is balanced. Now let's solve the next question, that is barium chloride plus aluminium sulfate which gives barium sulfate plus aluminium chloride. So we know we have to convert the statement into its element form. So barium chloride, we know we should write barium as Ba and chlorine as Cl2. Then aluminium as Al and sulfate as SO4 thrice. And barium sulfate we have to write as BaSO4 and aluminium chloride we have to write as AlCl3. Now we have to list out the elements that are given in the reaction. So they have given barium, chlorine, aluminium, sulfur, oxygen. In reactant side, we have 3 barium, and in product side also 3 barium is there. And chlorine, in here we have 3 2s are 6 atoms of chlorine are there. Here also in product side also 6 atoms of chlorine, and 2 atoms of aluminium are present in the reactant side, and here also in product side also 2 atoms of aluminium are present, and in reactant side we have 3 atoms of sulfur, so we have written 3 here, and in product side also we have 3 atoms of sulfur. See here, sulfur 3, so we have written 3, and the last element oxygen, here we have 4 3s are 12, 12 elements of oxygen is there in reactant side, and in product side also we have 12 atoms of oxygen. So now when we compare the number of atoms in the reactant side is equal to the number of atom in the product side. So from this we can say that this equation is balanced and it satisfies the law of conservation of mass. Now let's move to the third one, that is sodium plus water, which gives sodium hydroxide plus hydrogen. Here for sodium we have to write Na, for water we have to write H2O, for sodium hydroxide we have to write as NaOH, and hydrogen we have to write as H2. Now the same we have to follow. We have to check whether the number of atoms present in the reactant is equal to number of atoms present in the product or not. Okay, first sodium. Here we have 2 atoms of sodium, so here 2, and here also we have 2, so 2 present. And here we have 4 atoms of hydrogen, and here also we have 4 atoms of hydrogen, and here we have 2 atoms of oxygen, and here also we have 2 atoms of oxygen, and in here also the number of atom present in the reactant side is equal to number of atom present in the product side. So this equation is also balanced and it satisfies the law of conservation of mass. Okay, and this is how we have to convert the given statement into its element form, into its symbol form, and then we have to draw a tabular column like this, and we have to check whether the number of atom present in the reactant is equal to number of atom present in the product side. If both are equal, then we can say the equation is balanced. Thank you.